Hello everyone, my name is Du Zhixuan. My student ID is DSC2409009. Today, we're going to talk about the applications of derivatives to economics. This is the first part. Okay, let's in. First, we need to talk about the cost function Cx. The cost functions describe the total cost of selling products. This total cost includes two parts, fixed cost and variable cost. Fixed cost, for instance, the equipment depreciation. It doesn't change with changes in output, while variable cost is different. It's increase or decrease with increase or decrease in outputs. Okay, next we look at the marginal cost function. The marginal cost function is the derivative of the cost function, which refer to the additional cost of increasing 1 unit of output. It reflects the additional cost to produce each addition units of goods. Let me show you a simple instance. Tim Cooks. We all know that the Apple's current CEO Cooks. But we also know that Cook used to work in the supply chain. Now, let's assume that the cost function about iPads is this one. And then we can get the marginal cost function, this one. So what's the meaning of marginal cost function? It means that the cost required to produce each additional iPads. If 5,000 units have been produced now, the cost of producing another one is 415. This example may not be so appreciated, but I hope it can help you to understand the marginal cost. Okay, let's in the next part. Revenue function Rx. The revenue function is a function that describes the total revenue a company gets from selling a single number of products or services. These functions directly reflect the relationship between sales volumes and revenue. In a easy case, if price per unit of the product is fixed, then the revenue function can be expressed as this one. Rx equal to Px times X. The Px is a units price. It's a function. And X is sales volumes. Okay, let's explore the marginal revenue. The marginal revenue is the derivatives of the revenue function. It tells us how total revenue will change when sales volumes increase by 1 unit. In other words, marginal revenue is additional revenue from selling 1 addition units of the products. Let's take an example. AJ1. is popular in young people, isn't it? We assume that the function about aj1 is this. And then we can get the revenue function about aj1. And we calculate its derivative. We will find the Macron revenue. What's the meaning of the revenue? It means that we assume that 15 pairs has been sold. Then selling another pair will get 118 in revenue. Macron revenue plays a central role in economics. It helps companies to decide how to produce to maximize the profits. It's really important in economics. This is how the derivatives used for. Okay, that's in the next profits function px. Px equal to Rx minus Cx. It describes the net profit. It's the difference between the revenue function and cost function. The profits function reflects the economic benefits of the company, and it's very important to indicate or measuring the company's operating results. Okay, let's explore marginal profits. Marginal profits is the derivative of the profits function. It tells us how the total profits will change when the production or sales volumes increase by 1 unit. In other words, marginal profits is additional profits from selling 1 addition units of products. I will give you another example. This time, we will, it's a dream car of many people. BMW. Many people like it. We can assume the function about the profits function. We assume the revenue function and the product function. And then we'll get the profits function, this one. Then we will calculate its derivative. And finally, we will get the marginal profits function, this one. What's the meaning? Do you know? It means that for example, if 25 BMW have been sold, then selling 1 more BMW, you will get a profit of 27,000. Is it big money? Yeah. Marginal profits play an important role in economics too. It also helps companies to decide how to produce to maximize the profits. Okay, let's in the next parts. Here I will show you the washing machine. First, we look at the lecture. The lecture gives a description of washer. Sometimes sliding a slope of revolution result in discs with hole in the middle. We call them washers. This one. And then I will give you a formula about the volume. The Rx is the outer, and this one is R in. And then I will show you when we rotating a relation around an x, the relation is bounded by two functions. The resulting solve will have a hole. In this case, we cannot simply use the disk mass C to calculate the volumes because the disk mass C assumes the entire solve. Instead, oh, the entire solve is solved. Instead, we need to use Cauchy mass C by integrating the sum of the volumes of all the washes. This way, we can calculate the volumes of such solid with a hole. Okay, let's give you an example. Find the volume of solid of time by rotating the region between this one and this one about the x rays from x equal to 0 to x equal to 1. This is a formula. We put 1 to this, to B, and 0 to A. And outer array x is x, and the inner one is x squared. We put them into the formula, and then we'll get this one. Finally, we put the actual numbers, and we will get the final results. It's quite simple, isn't it? Okay, that's in the final parts. Here I will touch you the moments and the center of mass. It's seen in the lecture. The points on which a scene plane of any given shape balance is called center of mass of the planes. The product of the mass and of a product and its direct distance from a point is called the moment of the product with respect to that point. And then I will know the total amount and the center of mass. M of a system of n masses m1, m2, locates at the points x1, x2, along the axis is the sum of the individual moments. That is the sum of mi xi, mi times xi. The center of mass of the system is this one. It's easy, isn't it? Now I will give you a simple instance. Find the center of mass of a region bounded by y equal to x and y equal to 0, x equal to 0, and x equal to 1 with uniform distance. How to calculate this one? How to solve the problem? Here I will show you my step. First, we need to calculate arrow. The arrow function. The arrow formula is simple. We just put the row number, and we'll get answer. It's easy. And we will calculate x and y. It's easy, seen. Just need to calculate a simple formula, a simple function. Then we will get the points, the center of mass, this one. It's quite easy, I thought, isn't it? Have you now? Okay, thank you for watching.